seconds and counting.
Okay, guys, I'm noticing that every 4 minutes and 30 seconds, the sound cuts out. So I'm going to record multiple videos this time. So the next thing is a wind, right? The wind is the next factor. There's windward and leeward, okay? Windward and leeward. With windward, like the wind is pushing out and it comes more from the ocean, so it's more moist, while the leeward is dry, okay? And it's like it goes up and over. Rainy, wind, dry, lee. Cool. So here's an example of the precipitation in these certain areas. So this is, again, California. Obviously, you notice that I like using California as a reference because it has many terrestrial factors in it that I do like. So first of all, it's by the coast. It's by the Pacific Ocean. And then it has these Sierra Nevada mountain ranges. And then after that, it's this like really, really dry climate by Nevada. This is Nevada. Nevada is pretty much a desert. It's where like Las Vegas is. So when you have the windward winds like brushing out, okay, and then they come over here where it gets all this precipitation from the clouds, then all the way up and over, you get this like leeward, and that is causing that air and that wind to become more dry and continental because it like pushes up from the mountains and then it goes up, that leeward wind coming all the way down. Okay, so again, the factor is windward/leeward side of a mountain, and there it is, the prevailing winds that come from that windward side. Then it dries out and it's in the rain shadow on the opposite side. So the windward side is cooler and moist, as mentioned earlier, meaning the leeward side is the same, right? It's warm and dry. Well, it's not the same as windward, obviously, but it's the same as like what you think it may be. Like leeward is land's warm and dry, like continental. Here is another factor. So I just want to show you an image first, right? The white represents cold, and the thin black represents warm, meaning like these arrows. This is a dark arrow, it represents warm, and the lighter arrows represents cold currents. These are like ocean currents, right? So it's the flow of the ocean around specific parts. As you can see here, this is like very south of the equator and it's increasing in latitude, so it's colder compared to within the equator. It is nice and warm, like there's like no cold currents coming in aside from it being farther up north by the Arctic Ocean. So when you see here, these ocean currents affect it because with warmer waters comes warmer weather. With colder waters comes colder weather, okay? So again, the factors ocean currents, warm currents create a warmer climate, and cooler currents create a cooler climate, right? So that's a direct relationship with currents and climate. And just think of it as like the climate. I just want to reiterate this. A climate is not just the weather, it's the weather over a prolonged period of time. Like it's cyclic, it's always going to happen. So for example, the climate here is like in the winter it's always going to be cold compared to the climate where I lived in Texas. The winters are always going to be, pretty moderately warm. Isn't that nice, right? And again, ocean currents move in the same direction as prevailing winds. So the windward current, I believe it's windward. Let me go back. Yeah, the windward. I just don't want to say the wrong thing because I don't like that word. Have those prevailing winds that come up over the mountains and down toward the leeward. So there are a few other things that impact the climate that are not as important factors, but they're still something, right? They happen sometimes. So here it is in a nicer area. The things that affect it are this, condition, this phenomena called El Nino. El Nino, as we all know, it means a little girl. I'm just joking. It means a little boy. I get it, like a little boy. El Nino. Guys, I'm Spanish, so come on. Whoops. So that means that you probably can't hear me. So hold on. I'm going to escape.